All right, let's dive in. Today, we are going to pull back the curtain on one of the most powerful technologies out there, machine learning. We're going to break down what it actually is, how it really works, and where you're already seeing it probably every single day without even realizing it. So, let's get to it. You ever have that feeling where you're scrolling through Netflix or YouTube and it feels like it's reading your mind? It seems almost like magic, right? Well, it's not. The secret sauce is machine learning, a technology that learns your habits to guess what you're going to love next. So what exactly is it? At its core, machine learning is a way of teaching computers by example. Instead of giving them a massive, rigid list of rules to follow, the machine literally learns to spot patterns on its own, and that right there is the key. To really get how this all works, we're going to look at the three main ways machines learn. Think of them as different teaching styles. First up, we've got what's called supervised learning. And honestly, it's a lot like a classic classroom with a teacher and a student. This analogy is just perfect. Imagine you're learning to identify animals with a stack of flashcards. You see a picture of a cat, you flip it over, and it says cat. The computer gets the same kind of deal, but with data. It gets a whole bunch of information that's already been labeled with the right answer. And this image shows you exactly what's going on. You see all this labeled data, pictures with their names, like cow or elephant. This whole batch of examples, this training data, gets fed to an algorithm. It just keeps looking at examples until it starts to recognize the patterns. Eventually, it gets so good that when you show it a new picture it's never seen before, it can identify it all by itself. And trust me, this is everywhere. The spam filter in your email, it learned by looking at millions of emails that were labeled spam or not spam. The face recognition that unlocks your phone, the weather forecast, even the Zillow estimate for a house price. It all works by learning from data that came with an answer key. Okay, but what happens when you don't have an answer key? What if you just have a giant pile of data? Well, that brings us to our second method, unsupervised learning. This one is all about letting the machine dive into the data and find interesting patterns all on its own. The best way to picture this is to imagine giving a kid a giant, messy bucket of Legos. You don't give them any instructions. What are they going to do? They'll just naturally start sorting them, right? Putting all the red ones here, all the blue ones there, maybe sorting by shape. They are finding the hidden structure in the chaos, totally on their own. And this graphic shows that idea perfectly. We're just feeding the algorithm a bunch of raw, unlabeled pictures of animals. The machine has no idea what a camel is or what a horse is, but it can analyze the pixels and figure out, hey, all these animals look really similar to each other, so I'm going to put them in a group. And remember those creepy good Netflix recommendations? That's a classic example. The system groups you with people who have similar viewing habits. It's the same tech that online stores use to group customers based on what they buy, or to figure out that people who buy hot dogs also tend to buy buns. All right, our third and final method is, I think, the most fascinating of them all. It's called reinforcement learning. And this is where a machine learns the same way we do, just by trying things and seeing what happens. Pure trial and error. You know, if you've ever trained a dog, you already get the basic idea. The dog does the right trick, it gets a treat. That's a positive reward. Do it enough times, and the dog learns which actions get it that tasty reward. The machine is doing basically the same thing, just with data points instead of doggy treats. This little diagram shows that feedback loop in action. You have an agent, that could be an AI in a video game, and it takes an action in its environment. Based on that action, it gets either a reward or a penalty. That feedback goes back to the agent and the loop starts over. With every single cycle, the agent gets a little bit smarter, always trying to get the biggest possible reward. This approach is the secret behind some of the most mind-blowing AI breakthroughs. It's how AI programs mastered incredibly complex games like chess and Go. It's a huge piece of the puzzle for self-driving cars, learning how to navigate a busy street. And it's how you can teach a robot to walk just by letting it try and fail over and over again until it gets it right. So let's just put it all together real quick. Supervised learning, you've got labeled data, a clear answer key. Unsupervised learning, you've got unlabeled data, and the goal is to find hidden patterns. And finally, reinforcement learning. No preset data at all, just learning through rewards and penalties. 3 really different, really powerful ways for a machine to learn. Now, of course, in the real world, things are rarely this clean. A lot of the time, these different methods actually get mixed and matched, and they're all just one part of a much bigger, more structured process. A perfect example of this is something called semi-supervised learning. I mean, think about it. Labeling data is a ton of work. So what if you only label a tiny fraction of it? Well, it turns out that little bit of guidance, that little bit of teacher supervision, can help the algorithm make way more sense of the huge ocean of unlabeled data it has. It's kind of the best of both worlds. And it's so important to remember that machine learning isn't some kind of magic. It's a real engineering process. There's a pipeline. First, you have to get your data and clean it up. That's a huge job. Then you use that clean data to train your model, which is all the stuff we've been talking about. And finally, you have to actually deploy the model so it can be used out there in the real world.
So, we've seen how machines can learn to spot things, to group things, and to act in the world. They're already powering our movie nights, protecting our inboxes, and even starting to drive our cars. Which really just leaves us with one final and kind of exciting question. What should we teach